Looking to bring the power of machine learning to your iOS app? I'll show you how to get started with MLKit on today's Firecast. MLKit is a mobile SDK that brings Google's machine learning expertise to Android and iOS apps in a powerful yet easy-to-use package. Whether you're new or experienced in machine learning, you can implement the functionality you need in just a few lines of code. There's no need to have a deep knowledge of neural networks or model optimization to get started. I'd like to start out this video series on MLKit by showcasing one of the models provided by the SDK, MLKit's Text Recognition API for iOS. You can use this API to recognize text in any Latin-based language. Text recognition can automate tedious data entry for credit cards, receipts, and business cards. I'm starting out in the terminal. From the command line, I go to the projects directory and run pod init. Then I'm going to edit the pod file created by the init command. I'm editing right in the terminal, but you can use whatever code editor you prefer. I add 3 pods to the pod file: core, MLVision, and MLVision text model. The third pod, MLVision text model, is only required if you're using an on-device API. I'll just save these pod file changes here. Now I'll run pod install to install the required Firebase dependencies, and then open the XC workspace file to view my project. I build and run the project so you can get an idea of what we have so far. Right now, I have photos which clearly contain text, but the buttons to recognize text don't seem to do anything. Of course, I'll show you how to get them working. Before I add the code to my app to enable text recognition, I want to explain how the SDK handles it. First, I start with a UI image. Then, I initialize a vision image object, passing the UI image to the constructor. Vision image is an image or image buffer used in vision detection. From there, I process the image using Vision Text Recognizer, which is an on-device or cloud text recognizer that recognizes text in an image. I call process on the Vision Text Recognizer, which will then call a completion handler that has the optional vision text and error objects. Vision text is recognized text in an image. I'll get into the details of this object a little later. Finally, I pass vision text from my completion handler to a function to process the text and then display it on screen. Let's see what these steps look like in code. I start by importing the MLVision module. Here, I declare my text recognizer. In ViewDidLoad, I instantiate text recognizer as an on-device text recognizer. Then, the button action for finding text triggers the run text recognition function. In it, I create the vision image object, process it using the text recognizer, and then pass the closure parameters to the process result function, which displays the text on screen. When I check out the process result function, notice that it's rather empty right now. Let's talk about what this function does. In order to better understand how the process result function works, I'll examine the vision text object that was passed to the closure when I called textRecognizer.process. Vision text has 2 properties: text, a string of all the text found in the image, and blocks, an array of type vision text block. A vision text block is a text block recognized in an image. It also contains string of the text. It has a frame and corner points properties to describe where the text block is in the image, as well as what languages were detected and how confident the model is in these results. Let's zero in on this one property, an array of type vision text line. A vision text line is a line of text recognized in an image. Noticing a pattern here? Finally, a vision text element is a text element recognized in an image. A text element is roughly equivalent to a space-separated word in most Latin script languages. So an element is basically a word. In many cases, you just need the text of the photo, so you can just access it using the text parameter of vision text. Other times, you may want to know the specific location of the words in the image, which is when you will need to access the arrays of text blocks, lines, and elements. In the process results function, I want to label words over where they appear in the image. So I iterate through blocks, lines, and finally elements to find the specific location for each word. Let's dive into the code for this. Okay, here I am back at process result. I first call remove frames to remove any previous frame views that may have been added from identifying text. Then I ensure that vision text has a value and that there is an image present. Right now I just return, but in a real app, you'll want to handle any errors. Time to iterate through the blocks in vision text, then the lines, then the elements, to get to the frames for individual words. Now I'm going to call add frame view, which is a custom drawing function that's already part of this project. It draws a frame on top of an image and prints out the detected text above where it is located in the image. Let's build and run the app so we can see some text recognition. Woohoo! It works! Congrats! You've now added text recognition capabilities to an iOS app. Feeling inspired to make a new project with MLKit? I'd love to hear about it. Tell me in the comments what you'd like to build with text recognition. Also, if you like this video, be sure to like, subscribe, and share so other developers can learn about text recognition and all the other cool videos that we have here. Thanks so much for watching, and I'll see you on a future Firecast.